Hello everyone. The present topic atoms and molecules, the concept of atom, symbol and laws of chemical combination. Please subscribe my channel, like and share. In the lower classes, 7th class and 8th class, you studied about the matter. Anything that has mass and occupies a space is known as matter. Matter exists in three states. What are the three states? Solids, liquids, and gases. Different substances combine following certain laws to form new substances, and these laws are called laws of chemical combination. The laws of chemical combination are law of conservation of mass, law of constant proportions, and law of multiple proportions. Now let us see the law of conservation of mass. What is law of conservation of mass? The matter is neither created nor destroyed, but one form of the matter can change into another form in a chemical reaction. The total mass of the reactants is equal to the total mass of resultants. Suppose you take a matchstick and burn it. When you burn matchstick, what do you get? Ash you will get, and of course some unburnt matchstick. Before burning, find the weight of the matchstick, and after burning is completed, collect the complete ash carefully and find the total mass of ash and unburnt matchstick. You will find the mass of unburnt complete matchstick is equal to the total mass of ash and unburnt matchstick. Now let us verify the law of conservation of mass. Law of conservation of mass proposed by Anthony Lavoisier. Take a conical flask and take a solution of lead nitrate, and in a test tube take a solution of potassium iodide and tie this with thread and fix a rubber cork to the conical flask. Find the total weight of the apparatus, that is the conical flask, test tube and two solutions present in it without mixing the chemicals. So find the total weight of the apparatus before or without mixing. Now shake the conical flask gently so that the chemicals mix with each other. So here, when the conical flask shaken gently, both the reactions mix with each other and the reaction takes place. Lead nitrate solution combines with potassium iodide and we get lead iodide and potassium nitrate. Lead iodide is an yellow precipitate. What is precipitate? An insoluble solid substance forms during the reaction is known as precipitate. Find the total weight of the apparatus after the reaction. Both the weights are found. Both the weights means before the reaction and after the reaction. Both the weights are found one and the same. Therefore, this verifies the law of conservation of mass. Law of conservation of mass states that matter is neither created nor destroyed, but one form of the mass can change into another form. Now let us do a small numerical and verify the law of conservation of mass. In a reaction, 5.3 gram of sodium carbonate reacted with 6 grams of acetic acid. Sodium carbonate formula Na2CO3, acetic acid formula CH3COOH. The products were 2.2 grams of carbon dioxide, 0.9 gram of water and 8.2 gram of sodium acetate. Show that these observations are in agreement with the law of conservation of mass. Now let us see the reaction Na2CO3 plus CH3COOH. Sodium carbonate plus acetic acid gives sodium acetate. The formula of sodium acetate is CH3COOH Na plus H2O plus carbon dioxide. Now the weights given in the problem are 5.3 grams of sodium carbonate, 6 grams of acetic acid and 8.2 grams of sodium acetate, 2.2 grams of water and 0.9 gram of carbon dioxide. Now the total weight becomes here 11.3, here also 11.3. So before the reaction the weight is 11.3, after the reaction the weight is 11.3, both the weights are same. Therefore total mass of reactants is equal to the total mass of resultants or products. Thus the law of conservation of mass is verified. Now law of constant or definite proportions, and this law was proposed by Joseph Proust. The law of definite proportions states that in a chemical substance, the elements are always present in definite proportions by mass. Whenever elements combine to form a compound, they do so in a whole number ratio irrespective of the method of preparation or source of availability. That means we can get a compound, a substance in different ways. We can prepare by different methods. In different sources it is available. For example, carbon dioxide is prepared in different ways and is available in nature in different sources. That is by direct burning of coal. If coal is burnt, we get carbon dioxide. By decomposition of limestone, limestone means calcium carbonate. Limestone is used in cement industry and we get carbon dioxide here. When limestone is heated, carbon dioxide we get. By respiration, what is respiration? Inhalation and exhalation of air. During this process, whatever the food we take that converts into glucose finally, the glucose formula is C6H12O6. The glucose in the blood combines with oxygen in lungs during the respiration and forms carbon dioxide, water, and we get energy. And this energy is used for our different activities. So here carbon dioxide is obtained in different ways. Not only that, carbon dioxide is prepared in many other ways also. By heating any carbonate or bicarbonate we get carbon dioxide. In all this, the carbon and oxygen elements combine in the ratio of 12:32, that is 3:8. That is, irrespective of the method of preparation or source of availability, the elements carbon and oxygen combine in the ratio 3:8, which is a fixed ratio. Now let us see law of multiple proportions proposed by John Dalton. When two elements combine to form two different substances, different weights of one element which combine with fixed weight of other element will be in the simple whole number ratio. Say two elements combine and we get different substances. For example, oxygen and hydrogen combine to form two different substances, water and hydrogen peroxide. Sulfur and oxygen combine in different ratios to form different substances, that is sulfur dioxide and sulfur trioxide. So here sulfur and oxygen combine to form sulfur dioxide and sulfur trioxide. So in both the substances the element present is sulfur has fixed weight. In both the substances sulfur has 32 grams, SO2, SO3. Only one atom of sulfur is there, therefore atomic mass of sulfur is 32. Oxygen has different weights. Here two oxygen atoms are there. Atomic mass of oxygen is 16 into 2, 32. Here three atoms are there, 3 into 16, 48. So oxygen has different weights. The ratio of different weights of oxygen is 32:48. This is 48. Therefore, which is a simple whole number ratio, that is 2:3. Now let us see the Dalton's atomic theory. By observing all the laws proposed by different scientists and of course by him, that is law of conservation of mass, law of definite proportions, law of multiple proportions, Dalton proposed certain points which constitute his atomic theory. All matter is made of very tiny particles called atoms which take part in chemical reactions. Atoms are indivisible particles, that is, they cannot be created or destroyed. Atoms are indivisible particles, that is, they cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and different chemical properties. Atoms combine in the ratio of simple whole numbers to form compounds. So all these are the different important points in Dalton's atomic theory. The relative number of kinds of atoms are constant in a given compound. That is, this statement is taken from law of definite proportions. Now let us see what is an atom. See, the atom is a smallest possible particle which cannot be divided into further simpler particles. So atom is the smallest possible particle of the matter that can exist independently and can take part in chemical reactions. Elements have the same type of atoms. Compounds have different types of atoms in a simple ratio. Element oxygen, for example, element oxygen has oxygen molecules and each oxygen molecule is made of 2 oxygen atoms. Water is a compound made of 2 hydrogen atoms and 1 oxygen atom. Therefore, the formula of water is H2O. Similarly, formula of carbon dioxide is CO2. Formula of sodium chloride is NaCl. Symbol. What is a symbol? A symbol is the cut short representation of an element. A symbol gives the information. What is symbol? Symbol is the cut short representation of an element. That means, while writing the notes or while noting, we have to write the names of elements frequently, which is very difficult. Instead of writing the name of the element continuously, we can represent that name with a symbol. A symbol gives the information, that is the name of that element, 1 atom of that element and mass of 1 atom of that element. Now let us see an example. Symbol of sodium is Na. So what does Na represent? Na represents 1 atom of sodium, mass of 1 atom of sodium, and of course Na itself represents the name of the element sodium. So here it tells the name of the element, 1 atom of element and mass of 1 atom of sodium as 23 units. Now let us see formula. A formula is used to represent molecule of an element or a compound. So the cut short representation of a compound is formula. Formula of carbon dioxide is CO2. A formula gives the information. See, formula also gives the same information as a symbol gives. Only the difference is symbol gives the name of the element, whereas formula gives the name of the compound. Or of course, in sometimes molecule may be present in elements also. So name of the molecule, 1 molecule of that compound, mass of 1 molecule of that compound. And apart from this, formula indicates the number of atoms of different elements present in that compound. For example, in carbon dioxide molecule, 1 molecule of carbon dioxide shows that it has 1 carbon atom and 2 oxygen atoms. Names and symbols of certain elements. So, as we studied, the symbol represents the name of the element and the symbol is the cut short representation of an element. So, we learn symbols of certain elements. Hydrogen H, helium He, lithium Li, beryllium Be, boron B, carbon C, symbol of nitrogen is N, symbol of oxygen is O, symbol of fluorine is F, symbol of neon is Ne, symbol of sodium Na, magnesium Mg, aluminum Al, silicon Si, phosphorus P, sulfur S, chlorine Cl, argon Ar, potassium K, calcium Ca. So practice all these elements with symbols every day once and 4-5 days. Therefore, you will remember all these elements thoroughly. Generally, the symbol of an element is the first letter. Then how do we write the symbol? So for writing the symbol, we have to follow certain rules. What are those? A symbol of an element has the first letter, and of course that letter should be capital letter. Some elements start with the same first letter. So already we studied certain symbols in the previous slide. The first letter of the element is taken as symbol. In some cases, certain elements have the same first letter. For example, carbon, chlorine, chromium, cobalt. See, all these four elements, they start with the same first letter. If we take the same first letter C as a symbol, then if C is written, then it gives a lot of confusion that C represents what element it is. Therefore, in the same manner, nitrogen, nickel, niobium, etc. Three elements start with the same first letter N. Now, in order to prevent this confusion, in such cases, what are the cases where the elements start with same first letter? The symbol of element is taken apart. The symbol must have two letters. Apart from the first letter, some other second or third important letter is included in the symbol. That is, that element has two-lettered symbol. Therefore, chlorine has a symbol Cl, chromium has a symbol Cr, cobalt has a symbol Cu. Here, please keep this point in mind. While writing the two-lettered symbol, the first letter should be capital letter and the second letter should be small letter. Small letter and small in size also. Similarly, symbol of nitrogen is N, symbol of nickel is Ni, symbol of niobium is Nb. Symbols of certain elements are taken from their Latin names. See, just now we studied that symbol of sodium is Na. Sodium starts with the first letter S, but its symbol is Na. How it is so? Because for certain elements, the symbols are taken from their Latin names. So, English name, Latin name, symbol. Sodium, Latin name is natrium, symbol Na. Potassium, Latin name kalium, symbol K. Iron, Latin name ferrum, symbol Fe. Copper, Latin name cuprum, symbol Cu. Silver, Latin name argentum, symbol Ag. Tin, Latin name stannum, symbol Sn. Antimony, Latin name stibium, symbol Sb. Gold, Latin name aurum, symbol Au. Mercury, hydroxyrum, Latin name and symbol is Hg. Lead, this is lead, 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 Latin name plumbum, symbol Pb. Tungsten, name wolfram and symbol W. So for all these elements, the symbol is taken from their Latin names. In the next module, let us discuss the writing the formulae. Thank you.